Now, another important rule, this rule number 5, which comes from your chain rules, is that ddx of k by u is equal to minus k by u square du dx, where k is a constant. Okay, example. Let us say if I want to find ddx of minus 5 by 2x square plus 5x minus 4. Okay, in this case, following the above rule, you see that u here is this, the denominator. This function in x is your u. Okay, this k is your minus 5. So according to the above rule, what you do is you take the constant out of the differentiation. So we write minus 5, okay, divided by u square. U square you see is the denominator. So we write 2x square plus 5x minus 4 square into the ddx of, that is du dx, right? And du dx means ddx of 2x square plus 5x minus 4. Okay, so this is what it is. Okay, so now what we do is we differentiate in our usual manner. Okay, just give me a minute. Okay, so uh, this is minus 5 by 2x square plus 5x minus 4 whole square, and this ddx, we have ddx of 2x square plus ddx of 5x plus ddx of 4. Okay, so this is minus 5 by 2x square plus 5x minus 4 whole square, and inside here you can take this 2 out of the differentiation to get 2 ddx of x square. This 5 again in the next one, you can take it out of the differentiation to get 5 ddx of x, and ddx of 4 is a ddx of a constant, which is 0. So this becomes minus 5 divided by 2x square plus 5x minus 4 whole square into, now if you differentiate all this, you will get twice. ddx of x square is 2x, ddx of x is 1, so 5 into 1, and plus 0. So ultimately get minus 5 times 4x plus 5 divided by 2x square plus 5x minus 4 whole square. Okay, so this is how you differentiate by this rule. Okay, so whenever you see a function below here, okay, this is how you will differentiate. In the denominator, if you see a polynomial function, this is how you will differentiate. Okay, let us take another example of this. Say ddx of, you want to find out 1 by 5x square plus 3x plus 7. Want to find out this, then we follow exactly similarly. See that k here constant is 1, so nothing doing here. So we'll simply have minus 1 by 5x square plus 3x plus 7 whole square into the ddx of du dx, right? So u here is this function 5x square plus 3x plus 7, which is equal to minus 1 by 5x square plus 3x plus 7 square into, we differentiate exactly in the same manner. This time let me just skip one or two steps. We have 5 ddx of x square plus 3 ddx of x plus ddx7. So ultimately what you get here is minus 1 by 5x square plus 3x plus 7 whole square. And then this one, you have 5 into ddx x square is 2x and ddx x is 1 and this is 0. So ultimately you get here minus, as in the numerator we put, and 10x plus 3 divided by 5x square plus 3x plus 7 whole square. That's it. Okay. So this is this rule. Now we come to the next part, which is differentiation of trigonometric functions.
Sir,
Yes, tell me.
can you show me the previous example on 7? No, not this one, sir. A. Beginning part of the A.
Okay. Let us continue with the next topic, which is differentiation of trigonometric functions. We'll be using these rules, but some more formula on trigonometric functions, and then we'll proceed to chain rules. Okay. Trigonometric functions. So what are the trigonometric functions that we need to know? What are the derivatives of trigonometric functions that we need to know at this stage? At this stage, what we need to know is, the first one is that the differentiation of sine x, you need to know, is cos x. Okay. The second result that you need to know is the differentiation of cos x. These should be by heart. Okay. These results should be by heart.
Yes.
You cannot have such problems cannot have you thinking. If I ask you ddx of sine x, in a fraction of a second it should come. Dx of tan x is equal to sec square x. Okay. Ddx of cot x is minus cosec square x. And fifth one, ddx of sec x is equal to sec x tan x. Okay, all these 5 results you need to know by heart. Okay, and before proceeding,
Sir, cosec.
yes, tell me.
Cosec.
Cosec I haven't given.
No.
Dx of cosec x is minus cosec cot. Okay. You can remember
Good
it
morning,
this way.
sir.
Good morning. You can remember it this way. ddx sine is cos, ddx of cos is minus sine, ddx tan is sec square, ddx cot is minus cosec square, ddx sec x tan x. Sorry, ddx sec x sec tan, and ddx cosec x minus cosec cot. This way you can remember. Okay. Now, before proceeding, just 2 simple examples, and then I will proceed with some problems and then chain rules. Okay. First example is, say I want to find out ddx of let's say x square plus 2 into tan x. So I want to find out the derivative of this. Okay, now what you see here is that this is a product of two functions, right? Just take this as u and take this as v. You can use your u v rule, u into v rule, use this, which is x square plus 2 ddx of tan x, right? This is how we differentiate by u into v rule plus tan x into ddx of x square plus 2. Okay, so now this becomes x square plus 2 and ddx tan x just above, if you see here, ddx tan x is sec square. So sec square x plus and tan x right as it is, and then you do your differentiation here. Can you tell me what should be the differentiation of x square plus 2? Let me see if you are comfortable with a little comfortable with differentiation. Can you tell me, Devanjan, what should be the differentiation of x square plus 2 directly?
So 2x.
2x. So now, so this part you are comfortable. Sumit Gupta, you are comfortable?
Yes.
Okay. Let me write directly then if you are comfortable. So this is x square plus 2 plus 2x tan x. That is your derivative or differentiation of x square plus 2 into tan x. Okay. Let us take another differentiation. Let us take ddx of, this time let us take sin x into tan x. Or let's take a reciprocal one. Let us take cosec x into tan x. Cosec x tan x. Okay. How do you differentiate this? Again, u into v rule. Consider this as your u, this as your v. Okay. The first function you take as it is, cosec x. Differentiate the second function. Next, take the second function as it is. Differentiate the first one. Okay. Let's take cot x. That will be better. Because cosec cot will ultimately give you a sine. So let's take cot x. Same thing we do with cot x. Okay. So cosec x and radius of cot x is what? Radius of cot x, let's see. Minus cosec square. Radius of cot is minus cosec square. Right? Plus, and this should be not, this should not be cot x. This should be cosec x. And this should be this should be your cot x. Right? U into v rule. So now this is cot x into ddx cosec x minus cosec cot. Right? What you ultimately get is minus cosec cube x, and this plus and minus combined to give you a minus. You get cosec x cot x. Okay. So here you have, now if you take minus cosec square common, cosec, not cosec square, you can take only cosec x common. What you get here is cosec square x plus cot square x. And that should be your answer. Okay. So once we have discussed these two rules, now we'd like to do some exercise problems before proceeding to chain rules. This is exercise 6A in my textbook. Okay, and the question here is differentiate with respect to x. I'll give you all questions at a time. Differentiate with respect to x. And questions are, first question is 7 by x square Next question here is 2 by x plus 1 by root x. Third is x to the power of 4 minus 2x plus 1 by x squared. Okay. Fourth one is 3x to the power of 4 minus x divided by x cube. Okay. And fifth question is 2x square minus 1 into x cube plus 4 whole cube. And we have your sixth question as x to the power of 4 plus 1 by root 1 plus x. Okay. And one last question here is x plus 1 by x, or maybe I'll do this after chain rule. Six questions will be okay. Okay, so let's start with the first one. Whenever you are given this kind of function, differentiate with respect to x, please your first step should be assume the function to be y is equal to fx is equal to 7 by x. Okay, this is what you assume. So therefore, your next step will be the differentiating y. dy dx is equal to, whether you write dy dx or whether you write f dash x, as I told you, it's the same thing, right? Is equal to ddx of 7 by x squared. How do you differentiate this? You will differentiate this by this rule, this one. Okay, here k will be ddx of k by u. So here, which is equal to minus k by u squared du dx, right? So if you see here, k here is 7, so we take it out of the differentiation, divided by u square. U here function is x square, so you will take it in the denominator. Okay, x square square into the ddx of x square. Okay, so this should be this should be 7 by x to the power of 4 into 2x. So 1x will cancel here. We get 14 by x. Now there's the minus sign also. This is minus, because here if you see in this rule, you have a minus sign here, right? I forgot this minus sign, so I'll just insert the minus sign here. Minus sign, you have a minus sign, and you, okay. So that is what this is. Next, now next function is 2 by x squared plus 1 by root x. So I start by saying that y is equal to 2 by x plus 1 by root x. So therefore, dy dx y is equal to, let's say, fx. 2 by x plus 1 by root x. So dy dx is f dash x is equal to ddx of 2 by x plus 1 by root x. So now we separate first ddx of 2 by x plus ddx 1 by root x. Next, you again differentiate this by what? By that rule, ddx of k by u. So k here is 2, you take it out, is equal to minus k by u square, isn't it? U here is x. into ddx of x. Okay, plus now ddx of 1 by root x. Remember, ddx of 1 by root x can be written as 1 by x to the power of half, right? So this now becomes minus 2 by x squared simply. So ddx of x is 1 plus ddx of x to the power of minus half. Okay, now we differentiate the second part by x to the power of n rule. So minus 2 by x squared plus nx to the power of n minus 1 minus half x to the power of minus half minus 1. So this is minus 2 by x squared minus half x to the power of minus 3. That's it. Or if you want a better way of writing, you can write it this way also. Minus 2 by x squared minus 1 by 2x to the power of 3 by 2. More better way of writing here, this is minus 2 by x squared minus 1 by twice. You can write x to the power of 3 by 2 as, from your laws of indices, if you remember, back in class 9, you have x to the power of 3 by 2 can be written as x to the power of half into 3, which can be written as minus 2 by x squared minus 1 by twice x to the power of half whole cube, which can now be written as minus 2 by x squared minus 1 by twice root x whole cube, because x to the power of half is root x. So minus 2 by x squared minus 1 by, now root x whole cube is nothing but root x into root x into root x. So combine two root x to get an x, right? So what you get here is minus 2 by x squared minus 1 by 2x root x. You can write it in a much more better way. You can, what you can do is you can take 1 by x common, okay, and you can write this as minus 2 by x minus 1 by 2 root x. Okay, so that is what. Now see, if you finish till here, you'll get full marks, no problem. Okay, but all this I have shown you the simplification, because later on, when you are applying derivatives, you'll be requiring these simplifications. Okay, so remember these simplifications. But if a pure differentiation sum is given, if you reach your answer, if you reach your steps till this part, you'll get full marks. Okay, let us do the next one. The next one you see here is number 3, which is x to the power of 4 minus 2x plus 1 by x. We'll finish the next two later on. So let's start by saying that y is equal to fx is equal to x to the power of 4 minus 2x plus 1 by x squared. Okay, so therefore dy dx will be equal to f dash x equal to ddx of x to the power of 4 minus 2x plus 1 by x squared. Now you distribute the differentiation over the entire polynomial or entire multinomial. This is a ddx of x to the power of 4 minus ddx 2x plus ddx 1 by x squared. So now you have ddx of x to the power of 4. Apply x to the power of n, you get 4x cubed. Minus ddx 2x, take 2 out, get 2 ddx of x. Ultimately, you will get 2. And plus ddx 1 by x square. Again, differentiate by ddx of k by x square. K by u, sorry. ddx of k by u. What was ddx of k by u? It's a minus 1 by u square into du dx. dx of x, right? So that's it. Now we get 4x cube minus 2 into 1 minus dx x square is 2x. So you have a 2x in the numerator, then you have x to the power of 4 in the denominator. So ultimately you get 4x cube minus this x here will cancel once, minus 2 minus 2y cube. And that is your answer. Yes, we have time for one more. Do number 4 also. Just I'll try to finish all 5 if I can. Anyway, let's see what the next one is. Next one here is 3x to the power of 4 minus x divided by x. So I say that y is equal to fx is equal to 3x to the power of 4 minus x divided by x. That is your question. Okay. Now remember, whenever you are getting, this is an important example, because when you come across this kind of a problem, what you'll be tempted to is you'll be tempted to use the u by v rule, isn't it? You'll be tempted to use the u by v rule, right? Now, instead of using the u by v rule, what we can do here is, first of all, we can cancel out the common factor between the numerator and the denominator by taking x common. We can simplify this a little. We can take x common in the numerator, so you get 3x cube minus 1. And the denominator x cube is there, so this 1x will cancel. So you simply get 3x cube minus 1 divided by x square. And again, we are tempted to use the u by v rule, but we shall not use the u by v rule. Whenever you have a binomial in the numerator and a monomial in the denominator, better is you split the fraction into 2. That is, you write this as 3x cube divided by x square minus 1 by x. And now what you can do is you can cancel out this 3 to a 1, and this x square completely cancels, okay, as 1. You simply get a 3x minus 1 by x. Now it is very, very convenient to differentiate, okay. So therefore, now we shall differentiate. Therefore, dy dx is equal to f dash x is equal to ddx of 3x minus 1 by x square. Split it. Take the constant out of the differentiation. Minus, now again this here, when we are doing this, we shall again use k by u. ddx k by u. ddx of k by u here is minus 1 by u square into the ddx of u. Right? That was the rule. So here we have 3 into 1 minus will combine to become a plus. And ddx of x square, you know, is 2x, and in the denominator you have x to the power of 4. This is simply, this 1x cancels here. You get 3 plus 2 by x. And that's your required differentiation. Okay, and I think I have only one more problem left. One more. X to the power of 4 by root 1 plus x. Fine. So number 5. Start by saying let y is equal to fx is equal to x to the power of 4 plus 1 divided by root 1 plus x. Okay. Now this you cannot do much with this. You have to use your u by v rule. Okay, so let us use the u by v rule directly. dy dx is equal to f dash x is equal to ddx of x to the power of 4 plus 1 by root 1 plus x. U by v rule, if you remember, it is v du dx. So So v here is the denominator into the differentiation of the numerator minus u, that is the numerator, into the differentiation of the denominator. Whole divided by the square of the denominator. Fine. Now we shall have 1 plus x. Now we shall differentiate. I take the liberty of differentiating x to the power 4 plus 1 directly to get 4x cubed. Okay. Minus x to the power of 4 plus 1. And now ddx of root 1 plus x. You remember the result ddx of root ax plus b? Let me see which this result. This one. ddx of root ax plus b. This time here we have ddx root 1 plus x you have there. So that means a here is 1 because the coefficient of x is 1 and b here is 1. Okay, and what was the result here? A by 2 root ax plus. So we'll write it here. A by 2 root ax plus b. A here is 1 divided by 2 root ax plus whole divided by 1 root 1 plus x whole square is simply 1 plus x. Okay. So that means now what you get is 4x cubed. Remove the brackets. For the brackets, 4x cubed root 1 plus x minus x to the power of 4 plus 1 by 2 root 1 plus x whole divided by 1 plus. Now you can take the LCM in the numerator. 1 plus x as the LCM. You'll get 4x cubed root 1 plus x into root 1 plus x minus x to the power of 4 plus 1 minus 2, twice of this, because there's a 2 also. Okay, twice of x to the power of 4 plus 1 divided by 1 plus x. Fine. So now what happens? You get 4x cubed root 1 plus x combined to give you simply a 1 plus x minus, you open this bracket here with 2x to the power of 4 minus 2 divided by 1 plus x root 1 plus. So you have, now you open the brackets, 4x cubed plus 4x to the power of 4 minus 2x to the power of 4 minus 2 divided by, this is 1 plus x. You can keep it as root 1 plus x root 1 plus x, or what you can also do is, depending on what you will be applying, so that is why I'm simplifying it a little further, and I'm showing you all the ways of simplifying this. You can write this as 1 plus x to the power of half. So this is now, if you simplify the numerator, you will simply get 2x to the power of 4 plus 4x cubed minus 2. And 1 plus x into 1 plus x to the power of half is 1 plus x to the power of 3 by, and that is your answer. Any questions?